Hello dear students. Today I am going to discuss question number 18 of the chapter on fluid mechanics. The question number 18 says we have a vertical triangular area with vertex downward and altitude h. Okay, and has its base lying on the free surface of a liquid. So we have a liquid. Let this pointer denote the free surface of a liquid, and we have a triangle whose base is flush with the free surface, and this triangle has an altitude of h. All right, so what we need to do is we have to find the center of pressure. All right, this question is based on the formula we have discussed in the question number 14. All right, so we can use the formula for finding the center of pressure, which is the distance of center of pressure along the plane of plate from the free surface is equal to the distance of the CG of a plate along the plane of the plate from the free surface plus the moment of inertia about an axis passing through the CG of the plate upon area of the plate times the distance of CG. All right, let us find these terms one by one. The first term is y bar. All right, so if we have a triangle of altitude h, then the position of its centroid is at a distance of h by 3. That is, the centroid of a triangle is at a distance at 1/3 of the altitude of this triangle from the base. So if this is the base, then the centroid of a triangle is at a distance of h by 3 from the base. So in our case, the base of the triangle is flush with the free surface, so and the plate is vertical, so y bar is h upon 3. All right, then the next term is ICG. Like in the previous case, we have to use the parallel axis theorem, which says that the moment of inertia about any axis equals the moment of inertia about an axis passing through the center of gravity plus the area times the distance between area times the square of the distance between the two axes. So suppose we have an axis, this is the CG, we have an axis passing through the CG of the triangle, and we have to find out the moment of inertia about the base. All right, so the moment of inertia about the base would be equal to the moment of inertia about the CG, about an axis passing through the CG, plus the area of this triangle times the square of the distance between these two axes. All right, since we have to use ICG in our equation, IB of a triangle, that is the moment of inertia of a triangle about its base, equals BH cube upon 12, where B is the width of the base of the triangle and H is the altitude of the triangle upon 12. BH cube upon 12, we need to remember this, the moment of inertia about the base of a triangle equals BH cube upon 12. Then minus area of a triangle is half of the width of base times the altitude. All right, then next term is the distance between the two axes, that is the axis passing through the base of the triangle and the axis passing through the CG, all right, which is y bar, and we have already found out the y bar, which is h upon 3. So h upon 3 squared. All right, then we can further simplify this equation as bh cube upon 12 minus bh cube upon 18. All right, so this equals bh cube upon 6 times 1 by 2 minus 1 upon 3. So this is bh cube upon 6 times 1 by 6 equals bh cube upon 36. All right, so the key to this solution is knowing the moment of inertia about the base of a triangle. Like in the previous case, in question number 14, we had to use the moment of inertia about an axis passing through the radius of a circle, which was pi d 4 d to the power of 4 upon 64, and in case of a semicircle it would have been exactly the half of the moment of inertia for a circle. So we have just found out ICG. Now the next term is a y bar. We have found out y bar, we have found out ICG. Now we need to find out this denominator a y bar. A is the area of triangle, which is half of the width of base times the altitude, right? And y bar is the location of the centroid from the base, and that equals h upon 3, which we have found out earlier. So this equals bh squared upon 6. All right, so if we simplify this factor, ICG upon ay bar equals bh cube upon 36 times bh squared upon 6. All right, so we can simplify ICG upon ay bar as h upon 6. All right, now we can plug in this value in the equation. YC equals y bar plus ICG upon ay bar as YC equals y bar is h upon 3 plus ICG upon ay bar is h upon 6. So we can write it as 2h upon 6 plus h by 6. So what basically I did is I made the denominator equal by multiplying and dividing by 2. All right, so this is 2h upon 6 plus 1 h upon 6 is 3h upon 6 equals h by 2. All right, so this is the conclusion, that if we have a triangle immersed in a liquid in such a way that its base is flush with the surface, then YC, which is the center of pressure, is at a distance of exactly the half of the altitude, all right, which is just below the CG, because CG is at a location of h upon 3, that is at a distance of 1/3 of the altitude from the base. So below the CG, like we have discussed in the question number 14, that the CP, center of pressure, is below the center of gravity or the centroid. So the right option for this is h upon 2, which is the option C. And this question has been asked in the engineering service examinations of 99. So a little bit important from for the competitive exams. So to conclude, we had a free surface, we had a liquid, and we had a triangle immersed in this free surface, and this triangle had an altitude of h. Then by geometry, the centroid is at a distance of h by 3 from the base, and from this formula, yc equals y bar plus icg upon ay bar, we have found out that the center of pressure is located at half the altitude, at a distance of half the altitude from the base. So if this is h by 3, then slightly below this point, this is the CG, and this is the CP at a distance of h by 2. Thank you for watching.